Everything is spinning. Right now. Earth rotates once every 24 hours. That's why we have day and night. Simple enough. But Earth also travels around the Sun. Takes a year. That's an orbit. The Sun, it's moving too. Orbiting the center of our galaxy. Takes about 200 million years for one lap. And the galaxy itself is rotating. The whole thing? Billions of stars, all going in circles around the center. Look at other galaxies through a telescope. They're spinning too. Almost all of them. Giant spirals. Look closer to home. Hurricanes rotate, tornadoes rotate. Even that little whirlpool in your bathtub, it rotates. Everything around you is spinning. And there's one hidden principle behind all of it. So here's the question. Why does everything spin? Why is rotation so common in the universe? Why don't things just move in straight lines? And here's a better question. If planets are orbiting the Sun, and moons are orbiting planets, and everything is moving in circles around everything else, why doesn't it all crash together? And you're part of this. Right now, you're spinning too. Standing on a planet rotating at 1,000 miles per hour. That's 1,600 kilometers per hour. Orbiting the Sun at 67,000 miles per hour. 108,000 kilometers per hour. Hurtling through the galaxy at 500,000 miles per hour. You can't feel any of it. Not a thing. Once you see the hidden principle behind all of this, the universe will never look the same. Let me show you. The moon is moving around Earth right now. Circling, orbiting. Why doesn't it fly away into space? Why doesn't it crash into Earth? It's moving fast. About 2,300 miles per hour. That's 3,700 kilometers per hour. So why the circle? Why not a straight line? Two things are happening at once. The moon wants to go straight. That's its natural motion. Newton's first law. An object in motion stays in motion in a straight line unless something pushes it. But Earth is pushing it. Gravity. Constantly pulling the moon toward Earth's center. So the moon is falling toward Earth, while moving sideways at the same time. The combination makes a curve, and if the sideways speed is just right, that curve bends at exactly the same rate Earth's surface curves away. The moon falls around Earth instead of into it. This is an orbit. Continuous falling that never lands. Think about that. The moon has been doing this for over 4 billion years. Falling toward Earth. Missing. Circling. Never crashing. Never flying away. Same thing with Earth around the Sun. Right now, we're falling toward the Sun. Gravity pulls us constantly. But we're also moving sideways. 67,000 miles per hour. That's 108,000 kilometers per hour. Fast enough that as we fall, the Sun's pull curves our path into a circle. We orbit instead of crash. Every planet does this. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, all falling toward the Sun, all moving sideways, all orbiting. The balance between falling and sideways motion creates stable circles that last billions of years. But here's the question that changes everything. Where did that sideways motion come from? Why is everything already moving when it starts falling? Go back to the beginning. The universe started with an explosion. Everything flew outward. Energy became matter. Particles formed. Eventually atoms, mostly hydrogen. These atoms spread through space, formed enormous clouds. Gas clouds light years across, just floating in the darkness. But these clouds weren't still. Nothing in the universe is perfectly still. There's always some motion, a push from a nearby supernova explosion, a gravitational pull from a dense region of space. temperature differences creating pressure waves, shock waves from dying stars, random disturbances from every direction. All of this creates movement. So the gas cloud is drifting, slowly, different parts moving different directions. The cloud isn't solid, it's gas. Different regions can move independently, some drifting one way, some another, some up, some down. Chaotic motion. Now gravity starts working. Parts of the cloud that are slightly denser pull harder. They attract more gas, get even denser, pull even harder. A feedback loop. The cloud starts collapsing, slowly at first, then faster. Gravity pulling everything inward. Here's where it gets interesting. As the cloud collapses, remember, different parts are moving in different directions. As they fall inward, they bring that motion with them. Some of that motion cancels out. Left motion cancels right motion. Up cancels down. But not all of it cancels. There's always some net rotation left over. The cloud as a whole has some spin, maybe tiny, maybe barely noticeable. But it's there. Think of it this way. Take 1,000 people running in random directions on a football field. Now tell them all to run toward the center. Most of the sideways motion cancels. Runners going left meet runners going right. But perfect cancellation? That would require every single motion to have an exact opposite. In a universe of random motions, that never happens. There's always some leftover direction, some net drift, some spin. And that tiny, barely noticeable spin is about to become the most important thing in the universe. Watch an ice skater spinning, arms stretched out, rotating slowly. Now watch what happens when they pull their arms in. They spin faster, much faster, way faster. They didn't add energy, didn't push off anything. They just moved mass closer to the center, and the rotation speeds up automatically. This is conservation of angular momentum, one of the fundamental laws of physics. Anything rotating wants to keep rotating, and when rotating mass moves closer to the center, the rotation accelerates. Now think about that collapsing gas cloud. As it falls inward, as the cloud gets smaller, any rotation it had speeds up, dramatically. What started as barely noticeable drift becomes rapid spin. The cloud begins rotating faster and faster, and as it spins faster, something else happens. The cloud flattens. Material that was spread through 3 dimensions gets squeezed into 2, into a disk, a rotating disk. Picture pizza dough. Throw it in the air, spinning. What happens? It flattens, spreads out, becomes a disk. The spinning motion pushes material outward, but only in the plane of rotation. The dough becomes flat and circular. Same thing happens to the gas cloud. It flattens into a spinning disk. Material spreads outward in the plane of rotation, gets compressed vertically. You end up with a thin, rotating disk of gas and dust. This happens everywhere in the universe. Every collapsing gas cloud becomes a rotating disk. Not sometimes. Not maybe. Always. It's built into the physics. You can't avoid it. Collapse plus any initial rotation equals a spinning disk. Automatic, inevitable, 2 everyday things, an ice skater and pizza dough, just explained how every structure in the cosmos begins. That tiny leftover spin from the chaotic gas cloud? Conservation of angular momentum grabs it, amplifies it, and forces it into a flat, spinning disk. Every single time. And what happens next at the center of that disk is where it gets really interesting. At the center of this spinning disk, gas piles up. More and more material falls inward. The center gets compressed, dense, hot. Temperature rises, pressure builds, millions of degrees. Eventually, the center gets so hot that hydrogen atoms start fusing together. Nuclear fusion begins. Hydrogen becomes helium, releases enormous energy. A star is born, and that star is spinning. Has to be. It inherited the rotation from the collapsing cloud. Can't avoid it. Our sun formed exactly this way, 4.5 billion years ago. A giant gas cloud somewhere in our galaxy started collapsing, spun faster as it shrank, flattened into a disk. The center became hot enough for fusion, the sun ignited, and it's been spinning ever since. One full rotation every 25 days. But here's what matters. The disk didn't disappear when the sun formed. Plenty of material remained, gas and dust orbiting the newborn sun, all moving in circles, all in the same direction, the direction of the original cloud's rotation. This leftover disk is called a protoplanetary disk, and it's where planets form. Over millions of years, particles in this disk collide with each other. When they collide gently, they stick together. Dust grains stick to other dust grains, make bigger clumps. Those clumps collide with other clumps, stick together, make even bigger clumps. Slowly, very slowly, these clumps grow. Dust grains become pebbles. Pebbles become rocks. Rocks become boulders. Boulders become mountains. Mountains become small planets called planetesimals, some of them hundreds of miles across. Eventually, planetesimals collide and merge into full-size planets. This process takes tens of millions of years, but it happens. And when it's done, you have planets orbiting a star. Now here's the critical point. Every planet was already moving before it became a planet, already orbiting. Because it formed inside a rotating disk. The particles that stuck together to make the planet were already moving sideways, already circling the sun. When they combined, they kept that motion. The sideways motion was built in from the start, inherited from the rotating disk. This is why all 8 planets in our solar system orbit the sun in the same direction. They didn't choose to orbit that way. They had no choice. They all came from the same rotating disk, same spin, same direction. Mercury goes around one way, then Venus, then Earth, Mars, Jupiter, Saturn, Uranus, Neptune, all circling the same direction, all following the original rotation of the disk they formed from, like grooves on a record player. If the planets had formed separately from different clouds, they'd orbit in random directions, some clockwise, some counterclockwise, different angles, different planes, total chaos. But they didn't form separately. They formed together, in one disk, from one collapsing cloud. So they all orbit together, same direction, same plane. And look at the plane they orbit in. It's flat, very flat. All the planets orbit within a few degrees of the same plane. Why? Because they formed in a flat disk. The disk was maybe a few million miles thick, but billions of miles wide. Very flat. Planets formed in that flat disk, so their orbits are flat too. Venus spins backwards. Probably a massive collision flipped it billions of years ago. The exception proves the rule. It took something violent to fight the natural spin. Everything else? Same direction, same plane, same reason. The disk decided it all before any planet ever existed. The planets themselves spin. Earth rotates once per day. Mars, about the same. Jupiter rotates every 10 hours. Saturn every 11 hours. They all spin. Why? Same reason everything else spins. As each planet formed, as material fell onto it from the surrounding disk, that material brought rotation with it. Not perfectly balanced, some net spin. As the planet grew, that spin increased. Conservation of angular momentum, again. The planet spun faster as more mass accumulated, and once spinning, it never stopped. Still spinning, billions of years later, even moons formed the same way. When planets grew large enough, some of them created their own small disks of material. Mini versions of the Sun's protoplanetary disk, material orbiting the planet instead of the star. That material collided, stuck together, grew, became moons. Jupiter has over 90 moons. Saturn has over 140, all orbiting, all moving sideways, all formed from rotating disks around their planets. Our moon probably formed differently. Most scientists think a giant impact happened. Something the size of Mars crashed into early Earth. The collision was violent, blasted enormous amounts of material into orbit around Earth. That material formed a disk, a hot disk of vaporized rock orbiting Earth. Over time, that disk cooled. Material collided, stuck together, became the moon, different origin than other moons, but same result, a disk, rotation, and orbit. The moon has been circling Earth ever since. Same direction Earth spins, because it formed from Earth's rotating debris. Disks, rotation, orbits. The same pattern, at every scale, from the gas cloud that became the sun, to the debris ring that became the moon. Now go bigger, much bigger. Galaxies. Galaxies. Our Milky Way is about 100,000 light-years across. That's roughly 600,000 trillion miles, or about 1,000,000 trillion kilometers. Hundreds of billions of stars, and the whole thing is spinning. How did it form? Same process. Exactly the same. Billions of years ago, an enormous cloud of gas, much larger than the one that made our solar system, started collapsing under its own gravity. That cloud had some motion, some slight drift. As it collapsed, conservation of angular momentum did its work. The rotation sped up. The cloud flattened into a disk. But this disk was immense, light years across, and inside it, smaller regions collapsed on their own, each one forming its own smaller disk, each one making a star with orbiting planets. So inside the galaxy-sized disk, billions of smaller disks formed, stars ignited, planets assembled, moons coalesced, all spinning, all orbiting, all following the rotation of their parent disk, which followed the rotation of the galaxy-sized disk, which followed the original motion of the gas cloud. Layers upon layers of inherited rotation. Look at other galaxies through a telescope. Andromeda spinning, the Whirlpool Galaxy spinning, the Sombrero Galaxy spinning. Billions of galaxies, and nearly all of them rotate. Same physics, same principle, from a bathtub drain to a galaxy 2 million light-years away. Same spin, same direction, same reason. But here's where conservation of angular momentum does something truly extreme. Remember the ice skater? Arms out, slow spin, arms in, fast spin. The closer mass gets to the center, the faster the rotation. Now imagine this, a star the size of our sun, spinning once every 25 days. Comfortable, slow. That star dies, runs out of fuel. The core collapses, violently. In less than a second, the core crushes down from something the size of the sun to something the size of a city. About 12 miles across. That's roughly 20 kilometers. A neutron star, same mass. Unimaginably smaller. Conservation of angular momentum takes that gentle 25-day rotation and compresses it. The result? Some neutron stars spin over 700 times per second. 700 full rotations, every single second. the surface moving at a significant fraction of the speed of light. If you stood on the equator of a neutron star, which you can't, the gravity would crush you into a layer of atoms. But if you could, you'd be whipping around at tens of thousands of miles per second. Same principle, same physics. Ice skater, pizza dough, neutron star. The only difference is scale. An ice skater pulls their arms in by a few inches. A neutron star pulls its mass inward by millions of miles. The physics doesn't care about the size. It works the same way, every time. Conservation of angular momentum doesn't have a maximum speed setting. It just keeps going. Compress the mass further, spin faster. No limit built into the equation. And that should make you wonder, what happens if you take spin away? Imagine Earth stops rotating. Right now. Just stops. The atmosphere doesn't stop. It keeps moving at 1,000 miles per hour. 1,600 kilometers per hour. Winds rip across the surface. Hurricane force everywhere on the planet. Simultaneously. Buildings torn apart. Trees ripped from the ground. Oceans surge sideways in massive walls of water. But that's just the first few minutes. Without rotation, one side of Earth faces the sun permanently. That side bakes. Surface temperatures climb to 250 degrees Fahrenheit. That's 121 degrees Celsius. The dark side freezes. Drops to negative 200 degrees Fahrenheit. Negative 129 degrees Celsius. No seasons, no day-night cycle. Just eternal burning on one half and eternal freezing on the other. Now go bigger. If planets stopped orbiting the sun, if that sideways motion disappeared, gravity would pull them straight in. Earth would fall into the sun in about 65 days. Mercury in a few weeks. Jupiter in a couple of years. Every planet consumed. No orbits, no solar system. Nothing left but a slightly heavier star. If galaxies stopped rotating, stars would spiral inward toward the supermassive black hole at the center. Billions of stars collapsing inward, the entire structure gone. Spin isn't decoration. Spin is architecture. It holds planets in orbit, keeps stars from collapsing together, maintains the structure of galaxies. Every spinning thing you see, from a hurricane to a galaxy, exists because it spins. Take the spin away, and the structure collapses. This is not optional. This is not incidental. Rotation is what gives the universe its shape. Back in the hook, I asked you a question. If planets are orbiting the sun, and moons are orbiting planets, and everything is moving in circles around everything else, why doesn't it all crash together? You already know half the answer. In Section 2, we saw how orbits work. The moon falls toward Earth, but it's also moving sideways, fast enough that it falls around Earth instead of into it. Continuous falling that never lands. Same with Earth around the sun. Falling inward, moving sideways, orbiting. But here's the part most people miss. It's not just that things happen to be moving sideways. That sideways motion is protected. Conservation of angular momentum doesn't just create rotation, it preserves it. Locks it in. Once something is spinning or orbiting, it resists changes to that motion. Think of throwing a ball. If you throw a ball straight at a wall, it hits the wall. Simple. But if you throw a ball sideways past a wall fast enough, it curves around. Doesn't hit. The sideways motion carries it past the obstacle. Gravity is the wall. Sideways motion is the throw. And conservation of angular momentum makes sure the throw never weakens. The ball never slows down. It keeps curving, forever. This is why the solar system is stable. Not because things are in perfect balance, they're not. Orbits shift slightly over millions of years. Planets tug on each other. The system wobbles, but it doesn't collapse, because the angular momentum is conserved. The sideways motion is locked in. It would take something enormous, a passing star, a massive collision, to change it significantly. Earth has been orbiting the Sun for 4.5 billion years. The Moon has been circling Earth for almost as long. Jupiter's been going around for the same duration. None of them have crashed. None of them have flown away. Not because someone designed it. Not because it's fragile and lucky. Because angular momentum is conserved. Period. The universe doesn't crash together because rotation is self-sustaining. It doesn't need fuel. It doesn't need maintenance. Once established, it persists unless something actively disrupts it. And in the vacuum of space, there's almost nothing to disrupt it. No air resistance, no friction, just empty space and gravity. The sideways motion continues. The orbits continue. The spin continues. Billions of years. Trillions of orbits. Still going. So the answer to why doesn't it all crash together is not complicated. It's not mysterious. It's angular momentum. The same principle that speeds up an ice skater. The same principle that flattens a gas cloud into a disk. The same principle that spins a neutron star 700 times per second. One principle, running everything, and we're not done yet. Because this principle has one more thing to show us. On Earth, we see the same spinning pattern. Hurricanes spin, tornadoes spin, even the water swirling down your bathtub drain, it rotates. Why? Because Earth itself is spinning. Earth rotates once per day. And that means different parts of Earth are moving at different speeds. At the equator, the surface moves fast, about 1,000 miles per hour. That's 1,600 kilometers per hour. But near the poles, the surface barely moves at all. This speed difference matters. When air flows from one latitude to another, it's moving over ground that rotates at a different speed. The air gets deflected, curves, starts rotating. This is the Coriolis effect. Earth's rotation bends the paths of moving air and water. In the northern hemisphere, moving air curves to the right. In the southern hemisphere, it curves to the left. That's why hurricanes spin counterclockwise in the north and clockwise in the south. Here's how a hurricane forms. Warm ocean water evaporates, rises, creates low pressure at the surface. More air rushes in to fill the gap. That incoming air gets deflected by Coriolis, bent into a spiral. More heat from the ocean adds more energy. The spiral spins faster. Winds build past 100 miles per hour, 160 kilometers per hour. A hurricane. Tornadoes. Same principle, different mechanism. Thunderstorms create powerful updrafts, columns of rapidly rising air. If wind speed changes at different heights, the rising column starts rotating, and then it gets stretched vertically. Conservation of angular momentum kicks in. As the column stretches, it spins faster, much faster. Winds over 200 miles per hour, 320 kilometers per hour. Tornado. Even water going down a drain shows the pattern. Any slight disturbance creates rotation. Once started, that rotation continues, gets amplified. Same principle. Everything spins because the universe started with motion, and gravity amplified it. Turned tiny random drifts into organized rotation. Turned chaos into structure, from hurricanes to galaxies, from your bathtub whirlpool to the Milky Way. Small gas clouds collapse and become spinning stars. Large gas clouds collapse and become spinning galaxies. The pattern repeats at every scale. Small gas clouds collapse and become spinning stars. Large gas clouds collapse and become spinning galaxies. Disks of gas around stars become orbiting planets. Same physics, same result. It goes back to the beginning. The early universe had motion, random variations, tiny differences in how things were moving. Those motions never stopped. They grew, got amplified by gravity, organized into the rotating structures we see today. Look up at the sky tonight. Every star you see is spinning. Every planet around those stars is orbiting. Every galaxy is rotating. All connected by one simple principle. Spin is conserved. Collapse amplifies spin. Rotation creates structure. That tiny, barely noticeable rotation in a collapsing gas cloud, the one we talked about at the very beginning, conservation of angular momentum grabbed it, amplified it, forced it into a flat spinning disk. And from that disk, everything formed. Stars, planets, moons, galaxies, weather patterns, everything you see when you look up at night. One principle running all of it. Remember that docking scene in Interstellar? Cooper had to match the spin of the damaged Endurance station, spinning out of control. Ranger craft approaching. If you don't match the spin, you can't dock. You can't connect. The whole mission fails. That's not just a movie rule. That's the universe's rule. Everything that exists, every star, every planet, every moon, learned to spin together. Formed from the same rotating disks, matched the spin of the system they belong to. If you don't match the spin, you don't belong. You get ejected, flung out into empty space. And here's the part that changes everything. The atoms in your body were forged in spinning stars. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all of it cooked inside stars that were spinning. When those stars died, they scattered that material into space. That material joined a spinning cloud. That cloud collapsed into a spinning disk. That disk became our spinning solar system. Our spinning Earth. You are literally made of spin. Every atom in your body has been part of this spinning story since before the Earth existed. You didn't just start spinning when you were born on this planet. You've been spinning since the beginning. You're standing on a spinning planet right now. That planet is orbiting a spinning star. That star is orbiting in a spinning galaxy, made from material that came from spinning gas clouds. The spin goes all the way back. That's why everything spins. Not because something actively makes it spin, because once it started, nothing stopped it, and gravity made it faster. Turned tiny random motions into grand spirals, turned chaotic drifts into elegant circular orbits. Spin is fundamental, built into the fabric of the universe. From the smallest whirlpool to the largest galaxy. Same pattern, same physics. And the next time you watch water swirl down a drain, or feel the wind of a passing storm, or look up at the stars on a clear night, remember, you're watching the same principle that built everything, the same principle that's been running since the first gas cloud started to collapse, the same principle that made you. If this changed how you see the universe, if you'll never look at a spinning top or a hurricane the same way again, hit that like button. Subscribe if you want more physics that makes you think, and leave a comment. Which blew your mind more? A neutron star spinning 700 times per second, or an ice skater using the exact same principle to speed up a pirouette? I'd love to know. Same pattern, same physics.